Good morning, good afternoon, and good evening, everybody. My name is Karol Skrzonski, and I welcome you to another episode of Loosely Coupled by Bridging the Gap. And I see that my connection just got ripped, so I don't have my logo back on the screen. Well, that happens. Hopefully, everybody has a nice refreshment for this conversation because today we're going to be probably, well, breaking quite a few minds and breaking quite a few concepts because today on Loosely Coupled we have no other than Barry O'Reilly, who's been known to, well, not to literally, but cracking people's heads with concepts that are, well, to a lot of them, groundbreaking. So, Barry, welcome to the show.
Yeah, thank you, Carol.
So, residuality. That's the thing you've been known for since what, 2023?
Well, it depends on where you've been in the world. Academically, 2019, at the big launch of the concept was, I guess, DDD Europe 2022 was the first big
Right.
talk on the
And then
subject.
you've been around and giving books and talking to people, and we have 2026, and now it seems that residuality is slowly taking over the mainstream.
It has, yeah. Surprisingly, it has become very mainstream. And as someone said to me, I was having a drink in a bar after a conference somewhere, and there's a guy, a guy called John Einer said to me, one minute you were this mad guy barking in the corner on Twitter, and now you're everywhere. How did you do that? And I have no idea. I know. It just kind of happened. It wasn't intentional. I didn't think it would ever get this far. I'm glad that it has. It gives me hope for the industry. But yeah, it's been a it's been a wild ride the last couple of years, I have to say.
Right. So, what is it? Two books now published. Third one in the works, or
Yeah,
is the third one already?
two books are published. The third one is in the works, and the fourth one, which is going to be my PhD thesis, is going to be released roughly around the same time as the third one. So
Okay.
it's going to be a wild 2026. We're getting all of this stuff out of the door.
So, for those who don't know where to find you, we probably recommend going to Lean Pub, right?
Lean Pub is where I sell the books. Yes, I haven't signed on with any large publisher yet. I just keep pushing that down the road. I know a lot of people are waiting on and want physical books, but we're still making decisions about what way that's going to play out. Because I enjoy the freedom of Lean Pub. I enjoy the lack of friction in getting new versions, new ideas, and corrections into the hands of readers. And I enjoy the money, all coming to me rather than some publisher who's done nothing except shout at me about grammar. And so I'm quite happy with the Lean Pub setup.
So, in that case, this one I'm holding is one of the very few.
There are very few physical copies. Yes, I think we made a couple of thousand, I think, originally with DDD Europe 2023. And there's been some limited runs in Belgium and Norway as well.
Okay.
But they're very rare. And I get emails every day saying, I saw this guy in a cafe. He had a physical copy of your book. Where do I get that? And I'm like, oh, I'm sorry. Do you have a printer? But it's been I haven't originally the story is cool story behind the book is that I gave a talk 2022 in Amsterdam at the Meervaart at DDD Europe, and it's very popular talk. I've been working on it for a very long time, and it was built, the academic papers have been released in 2019, 2020, 2021. And I was working on making the material sort of less academic, more approachable, and the talk went pretty well. And so after the conference matches at DDD Europe, he pinged me and he said, "Look, every year we like to give a book away to the conference attendees. Would you like to write the book for next year. And because because given the talk was so popular, and I thought, yeah, well,
Hmm.
that sounds good. I'll do that. I'll do that. And so around Christmas time, I was sort of slowly working on this. And I write when I write on my phone, right? So if I have a bit of downtime, if I'm sitting in a hotel bar or something, and I've got a conference, I'll just take my phone out and start writing. So I pinged
Hmm.
him, and I said, that's just it's going pretty well. I'm on like 260 pages now. And he wrote back in a bit of a panic. He was like, I think we have a different definition of book here because we were thinking like 16 to 24 pages. We can't really afford to print like 400 pages. And I was like, uh-oh, this is going to be a problem. And I said, don't worry, I'll sort it out. I'll sort it out. So I was at a conference in Munich, and I woke up. I went to bed. I remember going to bed and thinking tomorrow, and I was still sitting on 200 odd pages. I thought, I don't know how to make this 16 pages. I can't say all of this in 16 pages. So I thought, tomorrow, when I wake up tomorrow, I'm going to send Matt just an email. I'm going to say, I'm sorry, I don't think I can do this. I don't think I can produce a booklet. Um, and I got woken up at 6 in the morning by a text message from Lufthansa who said, "Look, I know you thought you were going home today, but you're not, because we've decided to have a strike, and
Oh,
yeah, good luck." And I thought I woke up and I thought, right, okay, and I thought, I mean, how long would it take? I thought to write 16 pages. It can't take that much time, and it's going to take me a very long time to get home today. So as I woke up and I was sitting there in the hotel, and I walked as I was walking to the train station, I started to write. I just on my phone, opened a new Word document on my phone, just started typing. And there was lots and lots of drama and diversions, but eventually I got home through Oslo, and I touched down at midnight, having left the hotel around 6, and and I just wrote the end, and that was it. And I was like,
okay.
and then I was able to write them to Matthias and say, hey, I have a new version. It's I know we said 16 to 24 pages. It's like 26 pages, but that's pretty close. And they were like, yeah, 16 to 24 small pages, not 16 to 24 very small text word pages. So this turned into 72 pages. But eventually we arrive at a compromise, and the book gets published anyway. And so the entire book was written in one day. Um,
So
so
I'm just checking. So the entire book that was published by DDD Europe is 63 pages
is
long.
it 63?
It's
Okay.
63. The
Yeah.
last number here is right here is 63 right here.
Okay. Oh,
Uh
we must have
yeah.
shrunk the text or something. And I wonder if that's one of the. I don't know. And so that's the story of how the book came to be. It was an accident. And so I sent off the files, and we did the art. My kid did the art, and Hilda at Ardling fixed it, and fixed it up and made it pretty. And then we got ready to release the book. And a few weeks before the conference, I start getting these emails with people, and they're going, I heard you have a book, and I heard it's coming out at DDD, and I'm not going to DDD. How do I get the book? And the first couple of emails that came, I was like, well, you don't. You have to go to you have to go to the conference. And then there were so many of them. I was like, oh, I'd better release this in some way. And so I just did a quick Google, where are people releasing books? And I saw that Gregor Hoppe's books were doing quite well on Leanpub, so I just went for it. And it didn't take a great deal of time, to be honest, to get the book into shape and published on Leanpub. And so I published it. I remember I was sitting there, it was 2 in the morning, and I published the book. And I got up the next day, and not early. I got up the next day. I was walking about, and I went into Leanpub, and there was the book at number one in the charts. I was like, "Whoa, what? How did this happen?" And it stayed there. It still dips in and out of the top 10 even now, but for 2 full years, it was in the top 10. It's been back to number one several times on Leanpub, and it's been. It's kind of taken by surprise the interest that was out there, especially given that the ideas are so challenging and not the easiest thing that you'll ever dig your claws into in terms of
Yeah.
software engineering. There's much more popular, much easier things that you can do. There are much more. They give you way more dopamine. That this would just.
Yeah,
But this seems to be quite popular.
I mean, just looking at the Head First O'Reilly series, these are very dopamine heavy books, right? They
Yeah,
really get you reading. They're very easy to digest in comparison.
yeah,
And I do remember your posts over the last 2 years when you were like screenshotting Lean Pop statistics, rankings, you and Gregor Hope chasing the first slot.
yeah. There was a little bit of competition there. We used to like go to conferences and talk the book up, and they'd be like, "No, I'm number one," and then he would go to a conference and come back up to number one. It was like it was a lot of fun, and we realized that the more we did this, the more books we both sold. So it worked very well to have that little bit of competition. It was kind of like Top of the Pops for nerds, you know. It was yeah, it was a
Fair
lot of
enough.
fun, a lot of fun doing that.
Well, in that case, for those who were at the DDD Europe and other conferences around where Barry was having those books, then you're the lucky few that actually have a physical copy. For the rest of you, if you don't know the books at all, here's the QR code to Lean Pop to Residues, and in a moment following by the QR for the Architect's Paradox, which is the second book of the series. Let's call it series, right? So Barry, because we were talking here in the studio before the stream, the origins of residuality, because for a change, because we talk to a lot of people here on Loosely Coupled, but very rarely I get to talk to an actual integration architect other than myself.
Yeah.
Right. So you were actually working in the capacity of an integration architect, as I do currently. You already joked that I'm a masochist for spending 15 years in the field. Fair. I
Yeah.
acknowledge, yes, that's a masochistic approach, definitely, to be 15 years in integration architecture. But tell us the background, because that's a very, very interesting thing.
Yeah, well, I came into the software industry originally through the Java programming language. So essentially, I'm a renegade mathematician who graduated in the late 90s in pure mathematics, and absolutely did not want to go to London and do the whole actuarial blah 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 pink shirt thing. Wasn't for me, obviously. And so I ended up then coming in through Java. I came in and got a job programming, and ended up just accidentally working in an absolutely enormous integration project. Using the hottest technology at the time, which was ASMX web services. So, yeah, real old stuff, and started to then realize that a lot of the things we were doing were already solved by different messaging protocols and by things like at the time, this was a very long time ago, burgeoning technologies, a very young technology called BizTalk Server from Microsoft, which was still finding its feet in those days. And I realized that all the most fun problems were there, in the where did this message go? What protocol should this be? How do we map and exchange this kind of thing? How do we increase latency? And the problems were much harder. On the integration side of things, I found myself sort of naturally drawn towards that. So I spent a very long part of my career working with those kind of things. And eventually I ended up doing an awful lot of work with BizTalk Server, an awful lot of work with a thing called Windows Communication Foundation,
Oh,
which was an incredible platform, which was severely neglected and abused by our industry, but it was a work of art, and no one appreciated it. And it died a terrible death. But I ended up working on a concept which way back in 2007, 2008, we called virtual services. And
mm-hmm.
today you would call it, today it would, the umbrella term would be API gateways. But what we were doing was we were
Hmm.
building these ghost services that would wrap and inject and inspect messages as they came from different systems. And so And that's how I ended up then going to work at Microsoft, and the integration thing took me into things like Service Bus, and then I worked in the TAP sort of technology adoption program for products like IoT Hub. I ended up doing a lot of
Mm.
large integration stuff with things like Event Hub Kafka based systems and IoT, large scale IoT systems, which is if you work in integration, that's where you want to go. That's where everything starts to break and all your ideas crumble and you realize you know nothing about anything. And that's, like I said, it's a form of masochism, and this is the height, it just gets harder and harder and harder. And so a lot of the ideas in residuality come from the concepts that I learned in integration and what I was seeing every single time, no matter how good the team was. They would build an application, they would design an application, they'd have an architecture, and then we would come along as the integration team, and we would help them with their architecture. Then we would say, well, you've missed a whole bunch of stuff. You're going to have to integrate this to this. These messages are going to have to flow from here to here. You're going to have to augment your system with these tiny little pieces that we're going to have to build around it in order to make sure that it survives in the big bad world. And so I started to, and one of the concepts in the book, you'll see the concept of the naive architecture, and that's when you build
Yeah.
an architecture without properly understanding the world that it's going to exist in. Um, a lot of architects would build a system, and then we would come along and look at that. I would look at that architecture, and I'd say, well, this system is, it solves the functional need that you have. It's got some pretty GUI. But we've got to add a whole bunch of things to it. And I started to see architectures as this naive structure that you initially build to solve a functional problem, and then a whole bunch of little chunks you've got to add on afterwards to make sure that it actually survives in the environment that it's going to be forced to live in. And I
Yeah.
started to see the building of a functional solution and the effort towards making a solution survive in its environment as two very, very different things. I think that's what started me along these lines of thinking.
At this point where I'm, looking back on my career where I started in the service-oriented architecture world, doing ESBs, uh, that was 2011.
Yeah,
For the frame of reference, the technologies you were talking about, ASMX Web Services originate originated in 2002. BizTalk was created in 2000, but the golden era of BizTalk was 2004, 2016, and
yeah.
was decommissioned in 2020, as far as Google says. So
It's
that was a product
decommissioned.
well lived.
Yeah. Yes, it's still alive. It's not decommissioned. It's still out there. There's so many
Yeah,
businesses are still running on it. There are many of them in a
they're just not
state of,
selling it anymore.
yeah, yeah. Well, they say that, but we'll see. We'll see. Yeah.
No, they already killed it and brought it back to life when Microsoft figured out that the product offering of Azure was not up to
Yeah.
standard of BizTalk. So they realized they don't have the right offering there. So we'll see how long that lasts because they still haven't upgraded Azure to that extent.
Yeah.
But,
Yeah. It's still, yeah. But I've got a lot of very
but
panicked customers at the minute. I can tell you
that's fair.
that.
Yeah, I never went into the Microsoft route on that, and I started in TIPCO Business Works,
Ah,
and then completely different path, analogous technology, analogous approach. We were building ESBs, we were building really humongous integration platforms that connected everything to everything. Well, not as literally, but thousands of integration flows.
yeah.
And the one thing that pops up from our conversation earlier, you also said that this is a wonderful way of learning everything because you have to learn so many various systems that you integrate because you cannot just rely on whatever the API is. You actually have to understand how that system works. Otherwise, you will not be able to integrate it properly, right?
Yeah, yeah, and I find this a sort of natural path for every integration technology that I ever worked with. I would tend to, you start off with a sort of superficial, well, we take these messages and we fire them over here at this endpoint and it'll pick them up and it'll do something. And then something goes wrong, they haven't told you the full story. The messages are different than what you thought. Messages start to disappear. As that starts to happen, you start to dig in, and before you know it, you've downloaded the entire document that describes the MSMQ protocol, and it's Saturday night, and your wife's like, "What are we doing tonight?" And like, we're reading this. We're going to figure out what actually goes on under the covers in this thing, and it builds up an intense amount of skill, right? So because once you really get into integration, you are not going to survive unless you really start to understand what TCP/IP is. You're not going to understand. You need to understand what messaging is and how messaging actually works and how these frameworks are implemented, and things like retries and availability and throughput start to become really, really important to you. And what I see and what I've seen across the entire breadth of my career is that people in the integration space tend to mature into architects much, much faster.
Mm.
And so if you're just building applications with functionality, yes, you'll have some concept of breaking things down into modular structures, but it won't be the same. Sounds like you're losing control of your JavaScript developers there, Carol. Um, um, the, and so I find, if I'm interviewing for architects and I see integration on a CV, then this person's going to have a fairly solid understanding of how a distributed system actually works, which is one of the most crucial skills we have to have today in this industry, regardless of what we're building or where we're building it. Whereas if
Right.
you're coming from a front end perspective, those things take longer. It takes a longer time to get exposed to those kind of things. With integration, you're thrown in at the deep end straight away, which
Right.
was a huge accidental step in my career. To be thrown in at the deep end is wonderful. It's scary at the time, but wonderful.
Right. I find it personally. I find it that about 50% of software architects or solution architects or whatever other title you add to the word architect I talk to have no idea what I do as an architect.
Yep.
And for the most part, people's understanding of integration, at least application integration, because there's also data integration. Let's leave it on the side. So people's understanding of application integration most of the times is limited to APIs, where under APIs they specifically mean what they call REST, and is actually JSON or HTTP. Where I love the Einer's comment on it last week on his talk. Bless their souls.
Yes. 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 I think that the way we talk about APIs is very much a symptom of where our industry is at. I would say that API integration is the explain like I'm five of software integration. It's simple, it's easy. People think once we do it, we understand this thing, but there's so much going on underneath. Um, that
There we go.
at least there's someone out there listening. I mean, that's good. The
Right.
so the what was I saying? Someone mentioned about integration. Yeah, so I tend to look very favorably upon architects with integration in their on their CV, because then they've done real nasty, scary stuff, and they've been in the guts of these protocols. They understand what it is, because all integration systems are by nature distributed. It means
Yeah.
they've fought the hard battles, and they're ready to move into cloud. So
Yeah. From my perspective, working in integration for the last 15 years, I mean, most people don't look beyond their own system.
yeah,
Whether or not they're designing a monolith or microservices or whatever in between in terms of distribution, uh, they don't look beyond that. They expose a layer of APIs if they do that, and that's done.
yeah,
That's it. Whereas the real distribution of architecture, well, the systems we work with, this is on the ecosystem level, because single company doesn't have one domain system. They usually
yeah,
have plenty, from 5 systems to 200 or more,
yeah,
right? if you go to global entities that span across the world and into their ITs and their shadow ITs and their regions, etc., that number can easily amount to thousands.
Yeah.
And this is the true distribution, and they're huge systems, not just a piece of code that is handling a very small scope of functionality. It's like humongous, often monolithic business systems that do a lot of stuff. I still have
Yeah.
horror stories in my head from integrating SAP R3. My favorite so far in terms of horror stories, luckily, S4HANA has a slightly better interface, at least readable, right? But that's that difference only.
Yeah. It's yeah, it is a fantastic way to test yourself is to move into integration, to learn these things.
I think this
Um,
comment is spot on here in terms of what we do as integration architects. The industry kind of forgot that we're integrating meaning and people in that sense, because that's a very much a negotiation role that we're having as integration architects to discuss with people what they have to do and how they have to do it, so that those systems talk to one another. And this kind of brings that. I feel after reading this book that it kind of is very much expressed there. I mean, I was reading parts of it and it was like constantly jumping to integration architecture. It's like, oh, this is like there. And then I asked you, and you were like, oh yeah, the origin is somewhere from integration architecture. It's like you can feel that
yeah.
to a small extent. You said something very interesting that, well, before the stream, not live, that integration platforms or integration application integration in general is a residue.
Yes, it is. I mean, this is so the concept of residue is this whenever if you take something, if you take a house, for example, and you burn it down, what's left over of the house is the residue. Right? There's just a bunch of ashes. Right? There's nothing left. That's the
True.
residue. Residue just means whatever's left from a process.
Yes.
And the way that I started to see architectures was that we have this original thing, this architecture, this little functional architecture, and then it gets burned down, right? It gets burned down by someone comes along and says this has to be integrated with the CRM system. We have to feed this data into the CRM system, and the architecture that is the house burns down, and you've got to rebuild it so that it can do what it did before, but also integrate with the CRM system, because the requirement to integrate with the CRM system, the architect of the original system didn't think about that. You've got to tear the architecture apart. And then we do that and we're happy it's integrated with the CRM system. And then someone comes along 6 months later and says, hey, you've got to integrate this with the ERP system. And the whole thing burns down again. You've got to rebuild it. And as an integration architect, this is what you were constantly, you would be called to a meeting, say, we have an integration project, we're going to integrate with this thing. And you would talk to the architects and you would realize that our whole thing burns down and we got to rebuild it. And so I started looking at application integration from this perspective. It's going to get hit by a whole bunch of stuff that isn't in the specification that you're not building for. And it's
Right.
going to burn down dozens of times. You're going to rebuild it dozens of times with a slightly different structure every single time. But if you're building a house, why not do this, right? Why not think, hey, this house might burn down. So let's have some fire doors and some fire blankets and some fire extinguishers, and let's have a safe where we put all the passports and all the, the deeds of the house and all that, so that if the house burns down, the residue isn't just a bunch of ashes, but it's a less burned down house, and everything that's very precious to us or irreplaceable is safe in the safe. And that becomes an analogy for what actually happens in an architecture, because one of the things that will happen as you try to build an architecture, at some point in the life cycle of your application, maybe 5 years in, maybe 10 years into the life cycle of your application, something's going to happen that you didn't know was there, that nobody knew was there, and it's going to cause you to look at the original architecture and say, uh-oh, we're going to have to pull this thing to pieces and we're going to have to put it back together in a slightly different way. And at some point in an application's life cycle, something's going to happen that no one had predicted. You're going to look at the architecture and you're going to go, uh-oh, it's going to cost more to fix this than to tear the whole thing down and just start all over again from a new clean slate. And we call that
Yeah.
technical debt, and everyone kind of knows that it's there, but we try not to talk about it, right? Because we don't want to upset the Scrum Master who needs to get something done. And
Right.
I started to think about architecture in terms of these residues. And so instead of thinking about an architecture as a fixed thing with a static structure and a predicted future, I started to see architectures as a bunch of residues, as a bunch of parallel futures. This architecture does not have one future. It has dozens of potential futures. I don't know which one it's going to have to live in, but it's going to have to live in at least one of them. And
Ooh,
as it moves through
that
times, there are all these parallel streams into the future of different architectures. And how do I get architects to think about those? And the concept of the residue was the way that I forced architects to think about the fact that the future is made of parallel streams, not one static future that you're going to predict.
that kind of hearing this is like uh, when I try to explain why
Mm.
the hell we have three abstraction layers on an ESB.
Yep.
It's like this is exactly why, because we
Yeah.
have those possible futures and we don't know which one's going to happen, and we build that composability on an
Yep.
ESB so that we can support that future somewhere.
Yep. Yep.
And basically, if I'm thinking, okay, you were using the analog of a burned down house, so I'm thinking in terms of how changes impact the all consumers, the whole ecosystem, if you have an integration platform and you don't have an integration platform. And basically from that analogy, it's like, oh yeah, the integration platform then becomes that fire blanket to just put out the fire when things happen,
Yeah.
small extent. Uh, Basically, it's like, oh yeah, we just take it over. You don't worry, we got it covered, right? It just
Yeah.
connected it.
Yeah. And another way that I like to think about the residue is, if you think about London,
Mm-hmm.
and they've built this massive thing at Tower Bridge called the Shard, this enormous, gorgeous, modern building. And you look at it and you feel very modern, right? And you think, wow, look at what we're able to do. But what you
Mm-hmm.
don't realize is that the architecture of that building, which looks so shiny and modern, has been determined first by a bunch of decisions that were made by a couple of Neolithic farmers 9,000 years ago who came to the River Thames and said, we're going to keep our cattle here, we're going to bury our dead here, over here in this hole, this is where we poop. And those decisions shape what's going to shape what happens when the next wave comes in, which is the Romans, where the Celts come, but us Celts don't really do that much. And so the Romans come and they do something useful, and they come along and they start building roads, and those roads are shaped by the fact that people say, well, they used to bury their dead there, so let's let the road swing this way. And that road then is formed and it's shaped by Roman needs, and then we build on top of that road, and we move through England's history, and eventually through the Victorian, and then all this red brick starts to appear, and then there's the Blitz, and a whole bunch of stuff gets destroyed, and then they rebuild, and suddenly the Shard, its sewage system that it's built on is Victorian. It's the houses that surround the Shard. There's a beautiful photo taken from a little street looking at the Shard where all the houses are red brick, and there are all these echoes of the past that are forming and shaping this thing, which we believe to be entirely modern. And this is the power of residue, right? The decisions that those Neolithic farmers made shaped the potential futures of the building that we call the Shard, as did the Romans, as did the Tudors, as did Queen Victoria. And these things are, this is how we need to look at architecture as well. When you make a little decision, that's the Shard, yes, but there's an even better photo of the Shard that's taken from a little street, and you can really see the history of London from that little street. It's all nice red brick and crumbling plaster, and a couple of those awful 60s buildings that they built after the Blitz. And this,
Unfortunately, not available on Google
okay,
that easily. You probably would have to spend a substantial amount of time searching through the
yeah.
images to be able to find that.
But the
But
thing,
that's what it
the
is.
point of that is that we believe that this architectural project is greenfield, but the residues that we set, the decisions that we make, cause echoes into the future. And
Right.
as an architect, you don't want to just be the victim of these echoes. You want to actually understand them. You want to understand what those echoes are going to be. So if I say this is going to be an API, what will the echoes of that decision be to the architect 10 years down the line who has to integrate this with a different system?
Right.
Or if I have three or two or one abstraction layers over this thing, what are those echoes going to be? What are they going to look like in the future? And once we start to
Mm.
think like that, then we turn. Once you start to think in this way, that's when you notice the weirdness in residuality. And the weirdness I found was that I didn't do what other people did. I didn't gather requirements. I didn't ask what are your non-functional requirements, what's actually going to happen in the future, what's the probability in all of this. Any intelligent person who works with those things knows that we're all just making stuff up most of the time, right? And the agile movement was smart enough to say, look, requirements, there's something funky going on here, because whatever they tell us is not what they actually want us to build. And so what I started to do was just make up a bunch of stuff that would stress the system. And I would think about these parallel lines. And I would say, what would happen if we ended up in this parallel stream? What would the architecture have to look like to survive there?
Yeah.
And what I noticed was when I started to do this, I started to stress wildly and randomly and without using probability or any of the tools I'd been taught, that seemed like good engineering practices and are preached as good engineering practices. What I started to realize was that these architectures, when you build them like this, they start to survive things that aren't in the specification. They start to survive things that we don't know about. And that's been what we've been
Hmm.
trying to do since the 1960s. That's the whole point of modularity. Survive things that
True.
aren't survive off spec. And I realized that. And so residuality can be described very simply as if you randomly stress your architecture, um, you will get an architecture that is better placed to survive unknown unknowns or off-spec events than if you use requirements or risks or edge cases or scenarios or any of these old traditional techniques that came from the engineering paradigm.
I
And
think, Barry, that a lot of people took too literally the paper by David Parnas and Paul Clements, a rational design process, how and why to fake it. And instead of
yes,
faking it, they started actually treating it seriously.
yes, they did. Yes,
Because back
yes,
in the day, David Parnas and Paul Clements already noticed that this we don't really have a rational process for software.
yes,
There
we
is
don't.
no means that we can build such a rational process. It's too much of a guesswork.
Yeah. And the advice in that paper is everything is chaos all the time. Get used to it. This is your life now. And then the second half of that paper says, but when you're talking to management, just lie. Just tell them that everything's under control, everything's structured, we know what we're doing. Hide the panic, don't scare leadership. But somewhere along the line, we started to believe in the people who were hiding the panic, and we started to believe that no, what we're doing is real solid engineering. We know what we're doing, and the panic kind of got swept under the rug. And so what I'm doing is I'm embracing the panic. I'm saying let's panic more. What happens if we just completely wet the bed, and start to panic, and that actually turns out to deliver better architectures. And that is an enormously provocative statement. I've had an awful lot of senior developers move to tears by that. How dare you say these things? And so, but when I realized how controversial the statement was, right, we've been taught for years how to find probabilities around risks, how to refine our requirements, how to be accurate, how to be correct, how to be right, how to protect ourselves from stakeholders who can't make up their minds. That when someone comes along and says, "Look, you do a better job if you just make shit up," that's deeply controversial. And so that's when I decided, look, it's not going to be enough for me to just write a book saying this. I'm going to have to go and prove that this is true. And that's when I went back to university and started the PhD, started developing real scientific experiments to be able to measure the effects of this. And
Right.
in doing that, that completely transformed the conversation, because I was no longer some carnival barker on Twitter saying that all your methods are philosophically flawed. I was now the person with a bit of paper saying, I have proof that this crazy idea actually works. And that just that one thing, that this random simulation gives us a result we've been looking for decades, is fundamental to the approach, becomes fundamental to the approach of software architecture. And once I had that and started to tour and talk about that kind of thing at conferences, you see this one industry guru after the other just slowly nodding their head and saying, "Yep, this, yeah, yep, we missed this bit," and that's where the ideas are gathering influence and power, because this is no longer Alan Kay's pop culture. Of software engineering. Now we're doing something that anyone experiments that people can reproduce and see this working for themselves.
Yeah, I love the new term you invented in the residues, hyperliminal. It
Yeah,
says a lot in the contrast between, because if you look at traditional engineering, you have, as you put it, when we're building a building, we're creating an ordered, complicated, ergodic system in a ordered, complicated, ergodic system, right?
yeah,
Because you will not change the laws of physics will not change suddenly. They will just remain as they are. So the environment we're building the building in is stable, is
yes,
described, is bound to the laws of physics. While this doesn't really happen in software, because, and now it's even more and more in that sense. 15 years ago, when I was beginning my journey in IT, this was already a chaotic environment, that a lot of things could go really easily because things shifted into a different direction, or the model just drifted away, right? I believe you talked about model drift quite a few times in your
yep,
talks. And basically the term hyperliminal that you use describes that we basically have a solid object in a completely fluid, ever moving environment that is constantly shifting and changing, and we're just trying to catch a snapshot and keep it in place, which is completely impossible. So
yep,
this is the key differentiator between traditional engineering that we know from, civil engineering, manufacturing, etc., and software engineering, which is a completely different environment in that sense, right?
yep. And that's why I think the concept of the hyperliminal system is incredibly important, because it shines a light on the fact that what we do as software architects is so different than what other engineers are expected to do. And I think the example I use in the book is, if you're an architect, a designer of the mechanical structure of a car, you can work with the laws of physics. You know that certain things aren't going to change. And software is more akin to designing a car when gravity isn't stable, when the properties of aluminium keep changing, when asphalt changes from day to day.
Yeah,
What would the design of a car look like? It wouldn't look anything like the design of a car looks like today. But yet we went to the people who designed things like cars and we stole all their methods. Because we wanted to be big grown-up engineers and use the same tools as them. And we took their methods without ever really questioning the fact that what we do is very, very different to what they do. And the hyperliminality, it helps to say that there are these two things. One is this little box of structured software, which we need to be in total control of, which we should be. And then you have this madness around it, this complex context, this business with people and employees and markets and all this madness moving and changing all the time. And it's our job to manage the relationship between these two things.
right.
And there's been a journey back and forth over 60 years. Who are we as architects? And we were just coming out of a little phase which was horrific, where we believed that it was our job to go into the unstructured part of the hyperliminal system, the business context, and bring structure to it, which is what enterprise architects thought they were doing. That we're going to sort everyone out. We're going to teach these people how to work with structure and logic. And the business world said, this doesn't work.
Nope.
Go to the basement and draw pictures for each other. We don't want to hear this. And that's what happened to enterprise architecture. So this is this is a really important concept. Sometimes people will say, "Oh, you just like big words. You keep making up new ones." But this idea that we have to deal with a type of system that nobody else is working with is incredibly important.
Right. I feel like people still don't grasp that the volatility that we're dealing with in terms of our environment, the context we're building software in, is compared to traditional engineering, you have 0 to 300% or more, right?
Nope.
And that volatility is increasing every single year. or every
Yeah.
single month, really, with the advancements in whatever we're doing. But it feels at times that what we're doing as an industry is we're running around with wheelbarrows and we don't even have time to load them. We're just
Yeah.
running around
Yeah.
without any sense, and it just increases in speed. So if I just recall last year's DDD Europe and the talk by Andrew Harmel Law, variability, the second hardest problem in software architecture. I don't know if you've seen that talk. There was this absolutely brilliant moment by the end of it where Andrew finished and there was still space for questions. And the first question and the only question that landed from the audience was, Andrew, you told us about the second hardest problem of software architecture. What's the first hardest problem? And he was like, oh, right, I forgot to tell you. All of you.
Yeah, very much.
Right?
Yeah.
So the source of all the variability, the source of all the volatility that we're experiencing in the industry is basically people. People, their ideas, their creativity, their fears, their whatever it is that is the emotional driver for people
Yeah.
to introduce changes.
Yeah, and I would say that there's two massive social things that have changed, that have completely warped our industry, and they have their roots, I guess, in the post-war boom, but really came to fruition in the 1980s. The first thing was the drop in transport costs. This enormous drop in transport costs that now makes it, financially viable. Today, there are bananas that are picked in Brazil, and they're shipped to Thailand to be washed. And once they're clean, they're shipped from Thailand to Europe to be sold. Now that makes no sense. It only makes
No.
sense if you A are sitting in front of a spreadsheet and that's how you make your living. And you say this is the cheapest possible way to do this, right? This saves us 1 cent per banana. And the only other way it's possible is when transport is incredibly cheap. And so the cost of transport and in general the cost of energy fell and caused these incredibly complex supply chains. And the second thing that comes along then is the internet, and suddenly the price of communication between human beings at any point on the planet, any point in the Western world, in any case, falls to almost zero. And when you get those two things happening, people and goods are moving at unprecedented speeds at a cost of virtually nothing, and information is flowing at a cost of virtually nothing across the world. It means that the social systems that we're building software for are now orders of magnitude more complex than anything we've ever had to deal with before. And we're using a bunch of patterns and ideas that have their roots in 1968 before this happens. So, and that's what causes us to get into trouble.
Right. And then, of course, as Alex puts here in the comment, we were dealing with, we're faced with essential acceleration, accidental acceleration, which I believe that, for example, the humongous AI boom and AI agents is that it contributes a lot to that accidental acceleration, not essential to it. And we're doing even more, even faster, and burning ourselves out because we can go faster
Yeah.
without
Yeah.
any reason to go faster.
Yes. And we don't see these things coming. We don't understand these systems. We don't understand the impact of the changes that we're making, and that causes our social systems to become unpredictable, our markets to become slightly unpredictable, and that means that building software based on people's picture of these things becomes incredibly dangerous.
Okay, so we covered residues. What are residues? Then, as far as the theory of the book goes, we still have stressors and attractors.
Yeah.
Right. So residues is the final outcome of applying stressors and
Yeah.
finding attractors, right?
Yep. So, a stressor, definition of a stressor is anything that's outside of your current mental model, right? So if you have a mental model of a business and there is a happening that you don't have in that model, let's say a price drop or a merger or an exchange rate fluctuation, or or someone blocks the Strait of Hormuz. Something happens that's not in your current mental model, or you're more successful than you thought, or you get new customers, or you break into a new market by accident,
Or a
um,
war breaks out,
or
or
yeah,
AI happens, or
yes, something like that. Then that is a stressor. It's not in your current model, so it will stress your model, and it will cause parts of your model to be questioned, to collapse, to need to be rebuilt. And as soon as that model collapses, your model of reality, your architecture is based on that model. So if the model collapses, the architecture is also at risk. And so what we do is we'll come up with this stressor, because they're easy to generate, and we'll say, what does the stressor do to the business environment? And the stressor will push the business environment. So if you, for example, a competitor drops their price, you have to counter that. You have to change the way you do things. And if you don't do anything, you're going to lose business, and that's going to be a change that's reflected in your architecture. And you might want to buy that competitor. You might want to lower your own costs. You might want to change your business processes. You might want to change suppliers. But there's going to be ripples that eventually hit your architecture. Your architecture is now on fire, just like your house. And you've got to
yeah,
ask, what are the fire blankets? What's the safe? What do I do to protect my architecture in the event that this thing should happen? And you look at your architecture, and you maybe shift a few component boundaries around, and you say the dependency between these two things would cause me serious issues in this situation, so let's minimize that dependency. And so you've made a little change to your architecture, and now you make that change and you go through the thought experiment. With this change, what will the residue be? The residue will be much, much better. And so you've improved your residue. Things are better. That's good. And then the change that you make, that's called the delta. That's a little augmentation to your naive architecture, and it might be a boundary change, it might be a new component, it might be a load balancer, it could be anything. And that little residue then becomes that little delta is the most important part of your residue, right? Because the rest of the residue is just the stuff that was already there. You've already talked about
hmm
that. And so you do this many, 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 many times. And the key to this method is volume. And every time you run this little loop, you get a little delta. And what you do at the end is you integrate all of those deltas together in a way that's reasonable. And that's where you've got to have integration skills to make this work. And that will give you a new architecture. And
right.
when you test that architecture and your original naive architecture against a set of unknown unknowns that they haven't been exposed to, you'll find that the new architecture stands up much, much better to a volatile hyperliminal system. That's the magic.
So,
Uh,
so
and
basically, that those stresses then is because I caught myself when reading the book. I caught myself that, oh, I'm actually applying parts of it.
yeah,
I'm actually stressing my architectural ideas. And when I'm teaching how to choose ecosystem architectural styles, so basically how to describe interoperability, the integration architecture for a specific ecosystem, I'm like, okay, what is there beyond the actual functional requirements that any client may have? Uh, what are the behaviors, typical behaviors? What are the potential behaviors, etc., going pondering further? So your look at stressors is going probably a lot further away from in terms of area of possibility than I would ever think.
yeah,
But I caught myself already that, okay, I'm already doing this to an extent. So, for example, if I'm looking at a specific client and I already know that they're, for example, acquiring startups and incorporating them into their business. So, in my head, that builds a mental model. Oh, we need probably a quality of removability
yeah,
because otherwise we'll have a large stress on the architecture if we build tight dependencies to whatever that startup produced and then rip it out and put a different startup in. That means we cannot really do that being closely interconnected. Oh, you need something in between, an abstraction layer like an integration platform to make it work. Okay, so that would be that residue.
yeah,
But then your stressors go way beyond that because
yeah,
my thinking of this, well, now I'm going to think about it differently, but my thinking so far was what has the biggest probability based on
yeah,
the current behavior, which is a good start, but not the right approach to apply residuality and stressor analysis.
Yeah, and this is where we start to part ways from the old ways of doing things. So one of the bits of feedback I get from senior architects who read the book or take my courses is that they'll say, but I've always done this. I haven't. I don't have. And one of the bits of feedback I got from Clemens Vastas, which I thought was fantastic, was he said, this is what we do when we build big stuff. He said, we don't have your fancy words for it, but this is what we do. And so when you look back through the history of architecture, which I think people need to be encouraged to do. And maybe we should have an episode about that sometime, just on the history of software architecture, because it was very, very weak on that.
Barry,
Hmm.
there'll be a chance for that,
Yeah.
because just a small disclaimer, and talking about this makes it happen in my book, because Mark Richards is considering stepping away for a while for a sabbatical. Considering, not yet. I pitched to him to do a whole series on history of IT.
Okay.
While he's sitting comfy on sabbatical, if he does that, then we'll be sitting and talking about the history of IT. So we're going to dig into old school RFCs. We'll dig into the purpose of XML, why the hell we invented XML in the first place, and why people hate it now, and all those things. Because what we already notice, if you're long enough in the industry, you notice these loops that people just do, reinvent the wheel anew.
Yeah.
We had XML, now we have JSON. JSON had to catch up to everything that XML offered by default. JSON started as a easy string-based format because there were no simple types in JSON at the beginning, as far as I remember. And then regular expressions, all simple types, complex types, namespaces even. These were things that were not present in JSON because it was not designed for it. Now we have them all. So basically we have a second XML. So we're reinventing the wheel. So that history, from that perspective, if you'd asked me 20 years ago, well, more than 20 years ago, when I was somewhere in high school, I would tell you that I hate history and don't want to learn history, because history at school was completely boring and I couldn't learn a thing. And I would say you wouldn't learn anything from history. But looking from the 15 years of my professional career, I say, oh, hell, we can learn so much from history.
Yeah, exactly. But where was I?
Sorry.
Yeah. So we so I was talking about, so senior architects will say, look, this is what we're already doing. If you go back through the history of software architecture, right? So you've got to ask the question, why don't we just solve our problems with a single file and some go-tos, right? Why don't we do that? That's the easiest way to do it. It's what most people want to do anyway. It's a natural sort of instinct. And every architect who solves a problem with a different approach than a single file with go-tos is making decisions. They're stressing their view of the world. They're saying this thing needs to be put over here because of this, and because this might happen in the future. And we're very aware, and we were very aware by the early 1950s, that change in the business environment was an extreme problem for us as an industry. And so what we see is that people start to realize that, oh, we've been taught to think in a very particular way. So if you go back to the history, and I'm talking about going back to the German logician Gottlob Frege and his influence on Bertrand Russell, and Bertrand Russell's influence on Wittgenstein and Turing and von Neumann, and the way that we look at the world around us as reducible to a bunch of logical prepositions. Which brings us to the computer, but also brings us to completely misunderstanding how the social world works. Then what we see is that we are all taught to think in a very particular way. And this is in all of us. And this is what the book, The Architect's Paradox, is about. And we've inherited this invisible philosophy of architecture, which we don't see, that causes us to reduce problems to logical statements, to structures, or to iteration. One of those three all the time. That's the only options we really have in our industry. And it forces us to think in a particular way about the world. It leads us to believe in things like probabilities, or that I can map out a particular social system with a structure and understand all the possibilities and capabilities and all of these things we got in enterprise architecture. Residuality then by its nature, actually has a different philosophy, and it says that actually you can't do any of that. There is this world outside the software is not governed by structure or logic, and it can't be solved by iteration because the structure of the software will still play a role. It has residues that echo into the future. And so what we end up with is a completely different way of thinking about how we experience the world around us. And the the way that this has been absorbed by our industry is like a virus. It's very hard to get rid of it, and it's very hard to get people to realize that residuality is a very different way of thinking than what's went before. And so people try to reconcile their old way of looking at the world with what residuality is, and that gets them confused. And it's, you don't look at it from the surface; you look at it from underneath. You look at it from underneath. You say, this is a different philosophical way of looking at things. We have a different idea about
Yeah.
probability. We cannot predict the future. We cannot control it. Software is rigid. It's not some complex, flexible, evolving thing. It's a rigid structure. But
Hmm.
and a business is not a rigid structure. It's a complex, evolving thing. And the conflict, the tension between these two things is where architecture should be focused. But we spent the last 60 years trying to make them either both structured or both fluid. But we're saying the residuality steps away from all of that, has a completely different philosophical foundation.
So, some time ago, when I was working as an enterprise architect, and I'm not very keen on returning to that role anytime soon, uh, I had a trainee, and she was trying to grasp and learn what the hell is software architecture. And instead of just sitting in a room and talking about architecture, I told her, okay, we're doing a field trip, right? So we went to Utrecht because our office was at the time in Utrecht. We went to the city center of Utrecht. We sat down with a cup of coffee in a plaza, and we're like, okay, what do you see? And there were people popping in from all sides, moving around, going away. Can you treat this as something that is structured, and can you treat this as something that is really deterministic, like a request reply? And of course, because she was learning from me mostly about integration architecture, and we were comparing uh, request reply to events, right? So can you think about it as request reply, something that you will have a deterministic answer when observing? So she was like, no, yeah, because all of these things are basically events. So all of this is basically a chaos of events happening all the time. And they're non-deterministic. Our nature as human beings is non-deterministic to that extent, right? And I've seen that people with that linear thinking that you mentioned also many times in the book, they really try to make everything very highly deterministic.
Yeah,
Where even in traditional engineering, we know that things are non-deterministic to a certain degree because everything has wear and tear, and
yeah,
only in the ideal physical space with no additions it is deterministic, right?
yeah,
So we always learn physics in the idealistic environment, which is
yeah,
non-existent, and if we put those the same concepts to an environment, this environment already influences the outcome,
yeah,
the determinism of an outcome, right? So
yeah,
we need to account additional variables to whatever calculations we're doing about anything, whether it's a building machinery, a chemical reaction, or whatever else, right? And we've been trying, I feel, a lot harder in IT to do so,
yeah.
and I believe it probably burned quite a few people out completely.
Yeah, but it leads to, a set of what we tend to do is we have all these tools that we've picked up over the decades, and the tools are very much linear in the way that they look at the world, and they come from what I call logical structuralism, which is the underlying philosophy of software architecture, software engineering.
Mm-hmm.
And what people do is they pick the, just like Parnas in that article you mentioned, they pick up all these tools, they make a little toolbox and say, this is the way I interact with the world. And then they interact
Mhm.
with the world in a completely different way. They use those tools, they use them on the surface, the mechanisms look the same, the rituals look the same, the ceremonies look the same, but they're actually stressing because that's how they get to a successful result. And so the story we tell about the work we do and the work we actually do are two completely different things. And
Right.
that leads to a lot of confusion because managers believe, oh, well, if you use this technique, you get this result. But architects know that it really doesn't matter which bag of techniques I use because all of us use different techniques, all of us use different ideas, different methodologies, but a good architect gets a result whether they're using one set of tools or another. And that's because the essential element of all of this is stress.
I think that the tools that we're using as architects, it basically is uh, a derivative of what skills we're lacking intuitively. So we're
Yes.
supplementing to those skills that we don't have in terms of how we observe and understand the world. So we use the tools that give us a broader understanding of the world
Yep.
that we're missing intuitively. If we have an intuitive grasp of certain aspects, we will not be using tools that highlight those aspects.
Yes.
So that's why we have that all those differences in what tools we're using, because everybody's thinking different and they have an innate ability to observe things in a different way, because our
Yep.
viewpoints are completely different, every one of us, right?
Yes. Yep. Exactly. But it takes some time to get there. I think as an architect to understand these things. It takes a lot of
Yeah.
perfection. We have a tendency in our industry to think that progress happens through tools. And our industry is built to deliver. So every time you go to a conference, someone has a new tool. Says use this tool to map this thing.
Yeah.
And the approach I've been taking from residuality is that it's not about tools, it's about concepts. It's about our theoretical understanding of how the world around us actually works, which leads to a kind of deeper philosophical investigation of what we do. And some people get very turned off by that. Some people are like, I want the explain like I'm five version. Give me the simple tool, right? Give me a spreadsheet and some boxes to fill in, and then I'll be happy until and it doesn't have to work. It's just another walk around the problem that allows me to structure my thoughts as I let my gut feeling run loose on this. Whereas residuality is really asking the question, what's underneath all of this? Why are we like this? Why do we do it like this? Why does this work and that work and this doesn't work and this works? And it provides a fairly powerful explanatory model for why architecture works the way it works, which I think is a step forward. I hope is a step
Hmm.
forward for us as an industry.
At least in understanding the industry, I would say so. At least I feel so, looking at the material so far, and your talks and so on. I think that's also why I started really enjoying domain-driven design so much in
Yep.
terms of concepts rather than the tools, because the tools are very useful, but they're only tools.
Yep.
But the concepts themselves, the aspect of clashing of mental models is the beauty. There's that beauty in it, because that really shows how non-deterministic our environment is.
Yep.
It's really goes into, okay, let's really look into what the hell's going on. So that at least covers that as is state, and then we can go to, for example, stressor analysis to cover that whatever to be state, to have it not tailored towards the as is,
Mm,
but tailored towards the realm of possibility, that non-linear aspect of reality.
yep.
Because if you look at this from, I don't know which part of physics that will be, but basically probably quantum mechanics, right? Past is linear, the now is now, and the future is non-linear, right? It's basically all the possibilities running until they are observed, right?
Yep.
That would be quantum mechanics, what it states. So if we don't know what's going to happen, then we need to kind of build for we don't know what's going to happen.
Yep. Yep.
And
And
I think that's what you're expressing to a large extent here.
yes, which traces itself back to not quite quantum mechanics, because I'm always very suspicious when people talk about architecture in terms of. I usually say if an architect starts talking about thermodynamics, leave the project, because Pseudoscience will not, it sounds impressive and some manager might be impressed, but it's not gonna build a good system. But I usually lean back on the philosophy of people like Henri Bergson or Gilles Deleuze, who talk about these multiple parallel futures and how we can deal with them. And these things were a reaction to the sort of positivistic philosophy of people like Russell, who had such a massive influence on computer science, who thought that the world could be reduced to logical propositions, and therefore code and our very existence were exactly the same thing. And if you were just smart enough, you could figure out how the world worked by looking through the language to find the code that's actually there.
Hmm. But yeah, well, you could try. I think that is a hell of an endeavor.
It failed miserably, and the only place it really continued was inside computer science, where we tried to do things like requirements engineering, to try and boil down meaning to a set of sentences, to a set of we call requirements, to a set of structures that are software applications. We haven't been so good
Right.
at that. We're still in this software crisis that was defined in '68. We're still there, and
I mean,
we're not really sure who we are.
looking at the history of evolution of different architectural styles, if you looked at the humongous failures of service-oriented architecture,
Hmm.
somebody whipped up the concept of a canonical data model.
Yep.
Yeah, that's the approach. We're trying to define everything by one cohesive language,
Yes.
which completely blew in people's faces
Yep.
very quickly, right?
Yep.
And that's why a lot of people now hate ESBs and so on because of those mistakes.
Yep. Very much. Yeah. Absolutely.
And we're trying to basically go with a model that is constantly drifting, and our mental models are drifting with it every day because we have pretty much a fresh mental model every day to a certain extent. It just changes, right?
Yeah.
So on the notion of uh, model drift, because I think that's an interesting concept, and I don't think that everybody is familiar with it. Can you shine some light on that, because
Yeah.
that's always a fun one for me.
Yep. So model drift is a phenomenon that we all experience as architects. So you have a model in your head of how a business environment works, and that model becomes fixed as soon as you translate that into software. You fix the model, and reality will start to move. It'll do its own thing. It'll go in a different direction than what you expected. And what happens is that reality and the model, or you believe they're aligned at one point in time when you make your architectural decisions, but as reality moves away, the model is actually drifting from where reality is going. I had a really interesting conversation with Chris Simon about this, and this is how
Oh,
the old way of thinking kind of puts us in a prison. And so I was saying that you have an architecture that's built on a model, and reality moves away, that model is broken and your architecture is broken. And Chris said, no, the architecture isn't broken. The architecture is exactly the same as it was. I haven't done anything wrong. And my architecture is not broken. Nothing, it's still working. It just doesn't work in that reality anymore. And I'm like, yeah, but that's broken, Chris. That's broken. And that's kind of the thing. We assume that, look, we've done the best we can. Our architecture is good. It's not good. It hasn't survived into that future. It is broken now. And so model drift is just whenever reality drifts away from your model, which you've made static in the software. And so you have to change your model to be able to keep up with that. And that's the fundamental problem of software architecture. The problem that we want to solve is model drift. Anybody can take a static model and produce an architecture. That's the easiest thing in the world, right?
mm-hmm.
Any developer can take a static model of a process or whatever and turn it into static code. So static models to static code is easy, but static code to a moving model is a different thing. That's what architects get paid for. And so model drift is one of the most important things. It's one of the first principles that we teach to architects to let them understand that this is the beast that you've chosen to fight. It's not as simple as the old textbooks tell us that it is. It's not just about gathering requirements and being clear and being sure about everything and being aligned and being in agreement. None of those things matter because reality doesn't care. It will go in its own direction. which we cannot predict or control or manage. And so we have to take a very different perspective on architecture as soon as we let go of the idea that we're in control of this drift. It's going to go where it wants, not where we tell it to.
Yeah, and I think that currently, what at least I'm observing is this humongous shift of architects moving towards business purpose than that technical aspect of architecture and building software. So a lot of architects are actually they start to invest in well, soft skills. I mean, they're not really soft, but we call them for some reason soft skills. They're investing in skills building understanding of business, building understanding of context, which I think it's a step in the right direction, because at least we will be able to understand that the context is always moving and shifting. I only fear, looking at what you wrote about probabilistics, is that they'll start to apply probability to what they learn about that business. So they start classifying different things that can happen in probabilistic chances: high chance, low chance, medium chance of things happening, and start designing against that. And that will be basically the failure here,
Yeah.
of that process, right?
I think this is an old idea that it's been around for a very long time, that we need to understand the business environment in order to be able to build software for it. And that's meant different things to different people across the generation. So this has its roots, of course, in the 1960s at IBM and things like business systems planning and those original. Um, there's a guy called Sylvie Kutasev in Australia who does research on the history of enterprise architecture, who tells this story particularly well. And the way that we have tried to understand business has changed over the years as well. It's very much driven by our culture and our understanding of things. And in the last 30, 40 years, we've had the MBA culture, where you have this kind of generalist expert who actually knows nothing but a bunch of general concepts that they've learned on an MBA course. And they come in and they tell you how to make profit and how to do all this. And we had the MBA president, which was, the second George Bush. And these ideas lead to us modeling our business as a set of structures, as a set of linear things. And this brings linear thinking to the business environment. And that leaked into enterprise architecture. So when I was being taught enterprise architecture, I was being taught by people who were worshipping the MBA and teaching me these kind of business school things. And this is how you map and this is how you model. It was just reinforcing the same old ideas. And
Mm-hmm.
it led to a very dangerous situation where I had colleagues who were enterprise architects who started saying very strange things. I would say, we're here to build a system. And they would say, no, we're here to tell the board what the right strategy is in this industry. And I'd be like, no, lads, we've lost ourselves here. We're techie guys. We build stuff, right? I said, if we understood the right strategy, if I actually believed that you understood the right strategy for this billion-dollar company, me and you would go and start a company, and then we'd never have to work again, and we could just go fishing. But we're not those people. We are not those people, right? We are not the strategists, and we get confused all the time. And it turns into
Mm.
this kind of macho Silicon Valley culture where everyone starts trying to show off that I know more about business than you know about business, and it ends up in this weird culture of enterprise architects who eventually get banished. They turn up in a board meeting. At one point, someone lets them in, or they sneak in, and they get their little PowerPoint out and they say, this is the future. This is the strategic direction that you could choose. We know this because we built networks with Windows NT 4. And then they get sent back to the basement, and the leadership will say, never allow those people in the elevator ever again. And that caused a lot of problems. So we do need to know the business environment, but we need to know the business environment, and this is something I'm very careful to do when I'm teaching architecture, that we need to know the business environment in relation to the code structures that we're going to build. And one of the
Mm.
examples I use when I'm teaching architecture is this idea of culture. What is corporate culture? Now, if you want to be the big expert and show off, how much you know about corporate culture. You can go off and you can read a whole bunch of authors, and there's a bunch of people reading Jung and stuff like that, and trying to figure out what a culture is. And then they come back and say, I can change your culture. Right, this is what a lot of agile coaches try to do this, right? We'll change your culture. We'll make everyone flexible. And then it didn't work. And like, well, it's your fault because you're all deeply inflexible people. And we just simply, culture is this thing that exists. It's a complex system. And I use a lot of complexity science to explain things. A culture is a complex system that emerges through the interactions of people in a market under certain pressures. And you can't predict it and you can't control it and you're not in charge of it. But you have to live in it. And you have to be able to sort of read it a little bit. Walk into a room, read the room, read what's happening in here. This is what we call soft skills. You've got to realize what way do people talk in this meeting? Who does all the talking? How do they make the decisions? What way do they treat each other? What way do they talk about each other? It gives you an idea of what the culture is. Why do you do all that? You don't do it because you want to be smarter than someone else or because you want to be popular. You do it because these things show up in the code. And I do some
Yeah.
exercises with my classes where we take a slice of code and we work backwards from the code and the code comments and we say, what's it like to work here? Who are these people? And you can
Ooh.
very, very quickly, I can look at a piece of code and say, this was written in this particular country at this kind of company, and I wouldn't want to work there, or I would want to work there. And so culture turns up in our architectures and it turns up in our codes. And when you're an architect, you have to realize that soft skills, when you learn soft skills as an architect, it always has to be related back to the job that we do. It's not like a hobby you do on the side so that you get on better with people, so that people feel better around you. Although, I mean, for a lot of us, that could be, good advice. But the point of soft skills, the point of understanding how a market works, isn't to show off how much you know a market or to become buddy buddy with
Yeah.
your clients and sell more hours. The point of understanding how a market works is so that I can build my architecture for the shifts that can happen in that market. And everything has to be related back to my job is to set software structure at a high level. And everything I do around soft skills, around markets, around all of that has to be, am I becoming better at knowing what this structure should be?
Yeah.
And we get lost sometimes and we can get a little bit confused about what's the point of us. And architecture has a problem with self-identity, right? We're not entirely sure who we are. An awful
That's
lot
true.
of, if you go to LinkedIn, you'll find at least 5 discussions a day with enterprise architects
Ah.
going, who are we? Why are we here? Although one of them discovered residues yesterday. Um, so which is good. But I did send him a little note telling him that someone already thought of this quite a few years ago. And they did write it down, so calm, calm yourself. But this is one of the failures I think of enterprise architecture, is that they tried to get away from the code in order to promote themselves as business people, and they lost the link between a lot of what we call soft skills and business skills, and
Yeah.
tech. And the architect has to be able to relate these two things to each other all the time.
I mean, looking at my lovely neuroatypicality, I went and started learning business analysis for the sake of broadening my tool set to actually acquire information and knowledge about the context I'm working in. To, for example, map out my stakeholders, so understand my stakeholders. Who the hell are my stakeholders, and what is their influence on my code base, and my dev team that is working with me? Because I found this a humongous value. The one thing I'm still probably going to be struggling with for the rest of my career is how to explain to people that an organization needs to change to adopt the architecture, because an architectural change that is significant also requires a change in behavior. And this is something that is often completely missed by a lot of organizations, which I believe, in terms of Martin Fowler's description of Conway's law, that would be called the inverse Conway maneuver,
Yeah.
right? And people still try to throw copious amounts of technology and architecture and code at social problems or socio-technical problems, right?
Yeah.
Uh, but being able to understand that context actually helps design and build architecture that is, to an extent, probably coping with that.
Yeah. Yes. And these are things that take a long, long time, decades to build up these skills. These are not things that can be taught in a college course.
No,
It's very much that fingerspetsfugle, that ability to, fingertip feeling, the ability to read a room and understand what's happening and understand that this particular idea, this particular architecture, isn't going to fly here. And normally, if you're presenting an architecture and you say, for this architecture to work, you all need to change. I mean, that's doomed from the start in my in my book. In most cases, unless you've got entirely new management and incentive schemes and things like that, people
yeah,
don't change because you shout at them. As the agile coaches figured out eventually,
eventually, yeah. But that's what it is. That's that variability coming to towards which we need to also design and take into account, that will probably stress our architectures a lot all the
Yes.
time. And I mean, I've been definitely told at times that I'm too strategic and not enough tactical because they needed changes quick without thinking about, do those changes actually make sense, and is that going to survive anything? Note, it
Yeah.
wouldn't, but they were convinced that they need to move faster than thinking occurs.
Yeah.
Uh, but
But
that's
it's
the curse of the industry at the moment.
yeah. But there's always a spectrum. I think if you've got a room full of people,
Hmm.
some of them will be thinking strategically, and some of them will be thinking, and some of them will be thinking too strategically. Some people will be thinking, oh well, let's not do anything for 5 years and see what happens. And some of them will be thinking, let's just start writing code now. Just open Visual Studio, let's go. And there's always a spectrum, and everybody always thinks that everybody else is wrong. Like my perspective is the right one. I am being perfectly strategic and tactical. I'm perfectly balanced. Everyone else is wrong.
Yeah,
And you have to find a balance in that. And as an architect, you have to be prepared for the fact that people are going to go off in a direction you don't expect in terms of long-term, short-term thinking, and your
true.
architecture has to protect against that. And that's the sort of thing that I teach when I'm teaching soft skills: is go into the room, listen to how they think, how do they make decisions, what's pressing these people, and you'll get a picture very, very quickly of, is this a long-term, short-term team, in a long-term, short-term, or long-term or short-term environment, in a long-term or short-term industry, what's actually happening here. And you can expect
Yeah,
variation. You can expect variation in that, and that's something to be survived, not steered, right? And so I've had architects saying, no, no, do you know what I do? I go in and I change them, I make them strategic. Like, no, you don't. I've never seen that. If you could do that, you'd be a billionaire. So, get out. A lot of there's a generation of enterprise architects who were roughly my age or a little bit older than me, who thought they were superheroes, and there was a real superhero narrative, about enterprise architecture 10, 15 years ago, where we could do anything and we could change entire companies. It was like Homelander the architect. Like it was embarrassing after a while, I think.
but that brings to my mind the conversation we had on Loosely Coupled with Woody Zool. You know Woody?
Yes,
Uh,
yes.
uh, we were talking with Woody about going beyond symptoms. So we're on a problem of identifying problems and identifying symptoms instead of, you know, just looking for a quick fix. And it's like, okay, Woody said something really interesting there. It was that when he goes into a room to listen and advise people, because he's mostly working as a coach, he always tries to pick up on specific words that are used over and over again because they tell a lot. And usually they point towards they are specific symptoms of a deeper problem somewhere there in the organization, in the team, in the whatever that is, right? And then that these kind of observations of behavior really tell a lot in terms of what is this organization experiencing.
Yeah.
And management, whatever that management may be, or business, whoever that business may be, however you define that, they always want to solve problems, but they see problems through that superficial symptom rather than through actually understanding the problem, which is where that approach into diving into the problem space goes, where we need to spend more time in the problem space rather than the solution space. It's a cardinal sin of many architects that they try to solution that in that linear thinking. Oh, I got the solution for that. No,
Yeah.
you don't.
Yep.
You basically don't grasp the problem yet, and you already have a solution. That doesn't
Yeah.
work that way.
Yeah, and this is why residuality has that concept of the naive architecture, because instead of trying to change people and say, don't do that, go problem first, then solution, I just gave up and
Mm-hmm.
said, look, just come up with a solution. Right? You're going to do it anyway. Your brain's going to do it. You're not in control of that. Draw the solution, and then we'll beat it up. Right? And that's how we'll get to it. That's how we'll work, rather than trying to force people into what for many software people is unnatural, into the problem space without solving it, which leads to meandering. And what they'll do is they'll meander for a few days to keep you happy and say, I've done the problem space wondering, and then they'll just come up with a solution randomly anyway. So we try to piggyback on that impulse in residuality and allow people to indulge in that immediate sort of dopamine based problem solving that we all do. Even though
Yeah,
we say the best practice is to explore the problem space. But definitely the biggest problem in architecture is under engineering and the inability to explore the problem space.
yeah. I mean, I loved it. I was reading this book. That was last year at DDD Europe, domain-driven
Yeah,
refactoring. I mean, Alessandro and Alberto really captured this very nicely in the introduction with attributing a quote to Einstein. If I had an hour to save the world, I would spend 55 minutes defining the problem and only 5 minutes finding the solution. And then went on to explain why should we actually care about the problem space and why should we dive into it instead of jumping to solutioning,
yeah,
because that solutioning then later costs us a lot more because then we need to actually refactor, right?
yeah, yeah,
And that is a key problem of that linear thinking,
yeah,
because that's where we're at in engineering. We see a problem, we fix it. That's
yeah,
a, also, if you consider psychology, that's a very masculine trait, and being in the men dominated industry, that's a very common trait, right? So we see a problem, we aim to fix it as quick as possible,
yeah,
even though we don't understand the problem, so it ends up a small band-aid on a gaping wound.
yeah.
But we're happy, we fix the problem.
Yep, absolutely. But on the other side, on the flip side of that, there is the problem we have whenever someone dives into the problem space and doesn't come back, and
Oh yeah.
they just keep going round and round and round, and never really arrive at anything. And even worse than that is someone who dips into the problem space and comes back absolutely certain that they've totally understood the problem. And in any
Ooh.
complex system, that's incredibly dangerous to have that level of, you need to have a certain level of humility when you're dealing with complex social problems and understand that, yeah, no matter how much I dive into this, no matter how smart I think I am, or which models I have, or how many people I've talked to, I do not properly understand this social system in the same way that I completely understand how a distributed system works because I've done all the reading, I've read all the stuff, I know how these things work. A social system is completely different. It cannot be mapped and structured and controlled and understood in the same way. And where fallibility is an immensely important topic in architecture.
I mean, if you put that, you understand that distributed system, but you understand it in an isolated, idealistic environment. Now, if you put it
Yes.
to context, which is that social system, whatever it may be,
Yeah.
you don't understand it anymore because
Mm.
it works in a context, right? It's on, and people tend to, oh, I understand the hell out of it.
Mm.
No, when you start applying it, you realize that you understand nothing.
Yeah.
And I think this is the beautiful picture here comes to my mind of the Dunning-Kruger effect and the
Yeah.
Dunning-Kruger curve. So the people who say they understand it, they're at the peak of stupidity in Dunning-Kruger effect,
Yeah.
and hopefully they'll land in the valley of despair. Because I
Yeah.
already seen a lot of people who never took the fall to the valley of despair, and they're just stuck on that peak. After they fall and go up, they never say they understand anything. They
Yeah.
they say, I have a grasp on it, I have an idea of it, I have a rudimentary understanding of it, and we can talk about it and see how that develops. but they're never at that level of certainty.
Yeah, yeah,
That
that's
naive certainty that basically comes with that naive architecture that you mentioned in the book, right?
yeah,
It,
yeah,
it basically is there. So it's interesting how that, see, this is already psychology transitioning into that architecture space
yeah,
is overlapping constantly. The moment we put it to context, we're like, boom, there we go. No certainty at all. There will never be a certainty in that aspect. And I
exactly.
think that's the thing that really bothers a lot of engineers that are traditionally trained, that
Yeah,
think linearly. They want certainty, and we're at the time and day where we have close to zero certainty because our profession is changing so fast, our environments are changing so fast, our businesses are moving so fast. How can you have any certainty? So the number of people that are actually in anxiety, fearing of their jobs right now,
yeah.
it's impossible to be certain about that at this point. I mean, I wish I would be, but even now I'm not certain, and I feel like I'm in a good position at this moment in life, but I'm not certain.
No,
I don't
well,
think
none, none,
anybody is.
none of us can be, But if it all goes to hell, yeah, well, I'll just do more fishing. I'm certain of that. So
Yeah, maybe I'll pick up carpentry again, right?
yeah,
That's at least what it can be, right?
yeah,
I mean, I've been trained as an electrical engineer. I know how to deal with metals, wood, and all sorts of things. So maybe that's a fallback, anyways. We'll see. We never know.
yeah,
It's probably going to be interesting if it all goes to hell and we have a some sort of a post-apocalypse. That would be entertaining,
yeah,
to say the least. But yeah, it's we'll see how it goes. But
yeah.
basically, yeah. Oh, we have some comments going in. Reduction of uncertainty. Yeah, definitely not the practice of certainty. What we do, it's
No,
a reduction of uncertainty, but again, not fully, right? Because we cannot reduce uncertainty entirely. Like, yeah,
yes. I mean,
and
we can feel better about uncertainty, but the uncertainty is always there. The only way to reduce uncertainty is to be certain about something. But to be comfortable acting in uncertainty is and this is one of the things whenever I was asked to originally teach architecture
mhm.
at Microsoft, and they asked me to, I said, what do you want me to teach? And they said, look, just teach whatever it is that you do. And I was like, well, there's a problem there because I have no idea what it is that I do. I just turn up in meetings and people seem very happy with it. I don't know what I do, and I started to dig into what is it that I do, and that's how I came up with residuality. And the one of the things that I discovered was that I was incredibly comfortable in highly uncertain conditions. I couldn't get rid of the uncertainty, but I felt comfortable. And I was like, this is the way it is, right? I know how to build systems when the conditions are uncertain. And as I talked to other senior architects and started to look at this, emphasize on this, I realized that yeah, this is what they do too. All of the people who are really senior, who are really confident, who are really good at this, they are completely comfortable. Walk into a room, you've got some stakeholders, and you say, "What do you want to do?" And they're like, "Oh, we don't really know." A senior architect is comfortable with that. A junior architect will start to crack and say, "I know I can't work with these people. They don't know their requirements. They don't know what they want." And the senior will say, "Well, of course they don't know what they want. They're business people, and nobody knows how any of this works, right? We just have to play the game." And
they maybe
yeah,
know what they want, but they don't know what they need.
yes, yeah, yeah. They maybe have an idea about what they want, and if you push them, they have to say something because they don't want to be seen as a person without any wants. But it's an incredibly uncertain environment that we work in.
Yeah.
And that's, you have to accept that. You have to be okay with that as an architect. And if you're coming from the programmer side of the house, where you're used to certainty, you're used to, when my tests are green, I know that it works. Or when this algorithm does what it says it does, and because it's logically sound and there's a proof for it, then moving into the architectural world of deep uncertainty in the business context can become incredibly uncomfortable. And that's one of the things that
Oh yeah.
residuality really forces you to look at. It lifts that stone and it says, are you comfortable with uncertainty? And the very act of stressing, random stressing, reveals very quickly how comfortable you are with uncertainty. How are you able to play with it? Are you able to be playful with these concepts? And it's one of the things that you look for when you're hiring an architect. Is this person going to be okay? Um, whenever there is no clear description of where the future is, and they have to just move somewhere, because that's what most of our jobs involve.
Yeah, I think that this is something you learn in stages, and to that extent, you're right that from my perspective at least, integration architecture, working in application integration, really prepares you better for that because you have a lot more exposure to uncertainty
Yeah,
than in any other aspect of IT. Uh, but it comes really in stages.
yeah,
I know that, for example, quite a while ago, while I was already very comfortable with uncertainty, I was very uncomfortable with volatility.
mm,
So if even if it was uncertain, it was fine as long as the pace of changes wasn't that drastic. The faster the changes were, the more uncomfortable I felt. Now, if I look at it, okay, am I still uncomfortable with volatility? Given that volatility surrounds us every day really, really drastically, and we see that it's just bonkers. Just looking at the recent events, like people go, "Yay, Mythos, Fable 5." 3 days later, nope, no
yeah,
more. It's like, yeah, okay, shit happened. I'm like, yeah, okay, fantastic. Moving on, next
yep,
topic. It's like a lot of people are still like, how could they? Yeah, they
yeah,
could. They could. They just did that. And I'm like reading those posts on LinkedIn, scrolling through them. Like every third post or fifth post is like Mythos Fable, Mythos Fable. Yeah, okay, next. I really really stopped caring about that because it's not something that shocks me anymore in that extent. And I think that
yeah,
this is that level of comfort to say I don't really care that it happened in the sense of that it doesn't trigger me emotionally, right?
yeah. It makes me think of a movie called Shaun of the Dead.
Ooh.
Have you heard of it where he says, look, you know, right, okay, sure, we're in a zombie apocalypse, but I'm just going to go down to Winchester, have a pint, and wait for all of this to blow over, and that's my current AI strategy, you know. This too shall pass. It's really not worth the energy. I've spent quite a lot of energy going, hey everybody, look, there's some statistical and philosophical problems with the speculation that's going on here, but nobody wants to listen to a statistical or philosophical analysis. People either want to go, hallelujah, we've solved all the world's problems, we're all going to be super rich, or this thing's going to kill us all. You know, people want to have their narratives. And you know, Hollywood movies, no one's going to the cinema anymore, so we've got to do something. So I'm not going to deny people their fun. I'm just going to wait it out.
Well, fair, but you triggered my ADHD to go down a rabbit hole right now. The rabbit hole called music, because you said this too shall pass. I'm like,
Yeah.
okay, go. I don't know if you know the band.
I don't.
Okay, go.
I've heard of them, but I don't know them. I don't know
They
them.
actually have a song called "This Too Shall Pass," uh,
Aha.
uh, which is a an amazing song. Very nice, very rhythmic. The fun part is that this song is the clip for this song is actually a Rube Goldberg machine,
Ah. Okay.
which is very interesting.
Yeah.
Causality all the way. But what people don't know, if you look close enough into the clip, it actually breaks in two places. So they have to stitch the video together from three different attempts
Aha. Okay.
because they couldn't make it run full and couldn't record it. So they actually made stitches somewhere in the video. And this too shall pass.
Yep. Yeah.
And they made a wonderful video and people liked it. And only if you're really nitpicky and go into like frame by frame details, you can see where the cut was. But
Yeah.
otherwise, it's like,
To
hey,
be
it works.
honest, Carol, it sounds like you did go into frame by frame detail because you know a bit too much about this, and it makes me wonder what does Carol do on a Saturday night? Well, now we
Nah,
know.
this song is like 16 years old.
Okay.
So that was at a time where I was like finding these different factoids, and I was like, seriously, I need to check it.
Okay.
Otherwise, now I just enjoy the clips because they have very creative clips for the sake of their music. That they just always went in a completely different direction than the industry. But yeah, this too shall pass. It will just pass. Yeah, we'll just move on to different things. And I remember your posts from like where when the LLM craze began and all the vibe coding craze began, and you were like, "Yeah, let them do that. I'm very happy. We're gonna have a specialization. We're gonna do vibe coding cleanups.
Yeah.
People were gonna hire good architects to actually clean up the shit that is built by AI, and we already see that happening. Literally,
Yep. Yep.
we already see those comments on screenshotted and posted on LinkedIn. Added 10,000 lines, removed 100,000 lines.
Yeah.
Vibe coding cleanup, right?
Yeah. I think you're starting to see a lot of people walk back their predictions and be a little bit more cautious about what they're saying. I've seen a lot of social media over the last few weeks where the hype cycle is starting to really slow down and people are starting to say, actually, this isn't giving us the benefits. I've heard on the grapevine that there are internal company reports showing that productivity is nowhere near where the kind of financial investment would make it feasible. And I think we're going to see many more sensible approaches as we move into the future, and it will
Yeah,
pass, and we will
yeah.
we will survive, and you know we'll
That's a
see what
nice thing.
happens.
Because I'm also looking as I'm always joking that my emotional intelligence is sitting about 5 meters that way in a different room while I'm working, because of my neurospicy flavor. I don't have any
Yeah,
emotional intelligence. That's just algorithms running in my head. And basically, she's fine with anything AI related, right? Cheerful as always. It'll be fine. It'll be good. This will pass. It's okay. And I'm like, yeah, well, other than a few turmoils around the thing, yeah. And then we look at, because I share a fascination in psychology with her.
mm,
She's working as an ADHD coach and is a special needs educator. So I'm like, okay, finally somebody I can talk to about psychology on a daily basis. So we share notes, and it's like if you look at the research done on AI and how AI changes how we work, or actually doesn't change how we work.
yeah,
Um, you look at the post from Dr. Laura Weiss on a cognitive load around AI. It's like we were promised to have a lighter workload on the day.
yeah,
That was the promise. Where is that promise? No, we still work 8 hours. Now we work more intensively because our cognitive load is higher, because now we delegated the easy stuff to AI, and now we focus only on the hard parts. So we are experiencing a lot of people being burned out. Now,
yeah,
great that those companies are increasing prices and tokens, because that will limit the usability of all the models.
yeah,
Fantastic. Then people will go down to actually doing those easy tasks so that their brains can relax for a change.
yep,
And that was a humongous uncertainty in all professions, right?
yep,
Not only IT, but writers, artists, musicians, anything related to marketing, etc., and go on and on and on.
yep,
It just passed. Now
yep,
people are adjusting. They still use AI, but less,
yep,
because they know that last mile is still requires human input, because
yep,
you can make certain parts easy, where in fact they didn't even need AI for that, but like deterministic automation,
yep,
which is another discovery for a lot of people, that they actually need, determinism in their life.
yep,
Or another discovery, and that's another one psychologically interesting, how little context we give one another
yeah,
in conversation, right? We assume context.
yeah,
And how many amazing misunderstandings are there because we assume context.
yeah.
it's interesting how this really changes and shapes us, and then we move on, and life moves on, and we cope with it somehow. And I think that's a good prediction for the future of our profession as well. We'll cope with that somehow.
Yeah. Yeah. What's the worst that can
Hopefully.
happen? We get to retire. So you get me.
Uh, yeah, I suppose.
Yeah. Get to do
Um,
get to do something else for a while. Oh.
that's always a possibility. I mean, yeah, there's plenty of people that shifted away from the professions they did for like 30 years and go did something completely different, because why
Yeah.
not?
Yeah. Millions of programmers left us in 2001, 2002, and went
Mm.
on and had happy and fulfilling lives, and didn't have to ever know what jQuery was or any of that
Oh,
stuff. and and it worked out for them. So,
well, then that means there's hope for us as well.
yeah, yeah, yeah. I mean, you have to be positive about these things.
We're joking in the course materials that when we teach integration architecture with Philip, we joke that in an alternative universe, we got fed up with IT and started just making pierogi.
Yeah. I could,
Because
I
we
could,
could, right?
yeah, yeah. I could imagine. I could imagine you full of doing that. Actually, that would be. I would come. I would eat your place. Imagine your little white aprons, with your beards in a little bag, making pierogi for the people. I mean,
Yeah, that would be
yeah.
basically
You have
it.
to be positive about the future.
Uh, and that's, yeah, that's fair. Oh, this is an interesting notion. We will become software archaeologists. I think that's on the comment on the AI topic and vibe coding. Aren't we
Yeah,
already kind of archaeologists in that space? When you're long enough in the industry, aren't you already an archaeologist next to being an architect?
I think going back to integration architecture, yeah, you're like, what is this thing? What does it do? Nobody knows who documented it. Nobody. So, well, okay, right, where's the source code? But yeah, there's a risk of, I think that if we go to producing huge enormous amounts of code without knowing what it really does, that you'll have to be an archaeologist in your own code. You come back in 6 months, you'll be like, who did this? And it was you, and you won't understand it, and it'll be difficult.
Uh,
And
I think
that
the
that's a
loop will
tr
be a
that's a
lot
tra
shorter.
that's a traffic tragic happening, right? That's it. At that point, I'll be coming and say, "Hey guys, you need a third person in your pierogi shop because this sucks." It's like,
Yeah,
yeah,
I mean, uh, I don't know about you, but as a developer, when was still working in the capacity of a developer, then I transitioned. Luckily, for the first few years, I was working for the same company. Well, as an end client, because then I shifted to be internal in that company. So I actually could work on the same code base for like 8 years straight,
yeah,
right? Which was extremely gratifying because I could see the actual fruits of my labor, both as a
yeah,
developer and then as an architect. And I was like opening a repository of code, and I was like, "Who the hell fucked it up this badly?" And then I go
yeah,
into SVN, look it up, look at the exact comments, and I was like, "Oh, I did 4 years ago." Okay,
yeah,
moving on. Let's fix it. But now that this loop of fucking up is actually a lot shorter, right? And
yeah,
the it's into months, not years, and that's horrifying
yeah,
to that extent, right? So
yeah,
we're literally becoming archaeologists, and we see that this is also that's been already tested as well.
yeah,
What was that experiment? They assigned 3 teams the same task of coding something, um, and then one of them had to do it traditionally without any AI support. The other one vibe coded, and the third one had some support from AI coding agents, right?
yeah,
And then they tested the actual understanding of what the hell was produced. So while the team that approached manually took the longest to build something, they actually knew every line of code and they understood the whole code base. While those that did vibe coding, they understood none of the code base. they produced the quickest.
Yeah.
But they had no idea what's happening in the code base. The one in the middle was in the middle. And
Yeah.
so, yeah, on the spectrum between the two. So it's like,
And they're seeing
in
this at
that sense, it's crazy.
they're seeing this at universities as well. University students who use AI to write their assignments are completely crashing out in the exams because they don't actually know the material. It's all just fleeting, and that's it's interesting from from the perspective of a society. Are we going to be this kind of just-in-time society where nobody knows anything, but we can click on some buttons and appear like we know for a few seconds? And what's the value of retained knowledge and things like that?
Right.
But
on that note, that we're going to be talking on the 9th of July with Chelsea Troy.
Okay, cool.
Because we scheduled with Tracy to talk about the future of education and how we prepare the new generation of software professionals in the age of AI wrecking completely our understanding of things and the need to comprehend what we're doing.
Yeah.
And that's another problem space to tackle, but this on a aspect of educational psychology and how we prepare professionals for work in the already non-deterministic environment of IT. That became even more undeterministic, and then we were forced into using non-deterministic tools to become even more undeterministic.
Okay.
So that's going to be a fun conversation on the 9th. That's going to happen because I think that there's a lot to it, even more. If I look at people coming now to joining the workforce, some of them are knowledge hungry and they'll probably survive.
Yeah.
But others are just doing 9 to 5.
Yeah.
They do what they're asked for. And that doesn't mean that they're retaining any knowledge.
Yeah. Yeah.
Maybe some limited amount. And I don't know, if you compare the current situation to how you learned, that's probably completely different, right?
Yeah. Yeah. Absolutely. Okay, should we wrap it up, Carol? Because in 5 minutes, Belgium are going to be playing their first World Cup match, and we might lose half our audience.
Oh, all right. On that note, you've been just invited. Yes, you're always welcome. You can take care of the beverages, and of course, well. We'll need to add you to our alternative universe just in case.
Yes, but we're going to have to build some residue, so there's going to be multiple alternative universes in which pierogi, is banned and all of this stuff. And we've got to build our residues. So
we'll shift to pasta. just to annoy Alberto.
Yes. Yes.
All right.
Pizza with pineapple, yes. Just to stay in line with Nick Tune's latest adventures. Thanks for having me, Carol.
You know the joke about pizza on pineapple? So while Italians finally come to grip that some people might add pineapple on pizza and with ham, etc., there come the Polish people that they do pasta with strawberries and cottage cheese.
Yes. I've heard about that, but I don't actually believe it.
No, that's actually a dish I ate as a child. Yeah, that's actually a true dish.
This is like drop bears in Australia. You just tell this to tourists just to freak them out.
No. This is actually a dish I was exposed to in kindergarten. We actually ate pasta with strawberries and cottage cheese. That's absolutely the truth of it.
Okay.
It is an existing dish in Polish cuisine. Hate it.
Yes, it sounds exotic. Okay.
All right. On the note of closing, next time around we're having the socio-technical API patterns and more with Einar Hust. We're going to be talking about some fun stuff then. That's on the 25th. Barry, thank you for joining. That's been a extremely fun conversation. There's a lot to that residuality theory that is, I think, extremely useful, and I'm happy that it's going mainstream because I think this will definitely shift the understanding of our lovely field for the better. Well, at least I hope it's going to shift for the better. We'll see what the residue is.
Yes, excellent. Thank you, Carol.